Let's take a question based on this chapter. First question, the concentration of hydrogen ion in the sample of soft drink is 3.8 into 10 power minus 3 molar. What is its pH? pH is equal to minus log of H ion concentration minus log of 3.8 into 10 power minus 3 minus log of 3.8 plus 3, because 10 to the power minus 3 log will be minus 3 into minus, that is plus 3. Now to take log of 3.8, there is one digit before decimal, so write 0 and see the log of 38 at 0. You will get 0.5798. 3 minus 0.5798, it will come out to be 2.42. So pH of soft drink is 2.42. Next question, the pH of sample of a vinegar is 3.76. Calculate the concentration of hydrogen ion in it. pH is equal to minus log of H ion concentration, or log of H ion concentration is equal to minus pH. Minus 3.76. Remember, anti-log of negative number you cannot see. So you have to add 1 and subtract 1. When you add 1 and subtract 1, minus 1 and minus 3 will become 4 bar. And from 1 you will subtract minus 0.76, you will get 0.24. Now you have to see anti-log of 0.24, which will be 1738. So you write down the decimal after first place, and this 4 bar becomes 10 to the power minus 4. 1.74 into 10 to the power minus 4 molar is the correct answer. The ionization constants of HF, formic acid, HCN at 298 Kelvin are 6.8 into 10 power minus 4, 1.8 into 10 power minus 4 and 4.8 into 10 power minus 9 respectively. Calculate the ionization constant of the corresponding conjugate base. For fluoride ion, Kb is equal to Kw divided by Ka. 10 to the power minus 14 divided by 6.8 into 10 power minus 4. It comes out to be 1.47 into 10 power minus 11. Rounding off, we get 1.5 into 10 power minus 11. Kb for formate ion is equal to Kw by Ka. 10 to the power minus 14 divided by 1.8 into 10 power minus 4. 5.6 into 10 to the power minus 11 will be the answer. For cyanide ion, Kb is equal to Kw divided by Ka. 10 to the power minus 14 divided by 4.8 into 10 power minus 9. Answer will come out to be 2.08 into 10 to the power minus 6. Next question, the ionization constant of phenol is 1 into 10 to the power minus 10. What is the concentration of phenate ion in 0.05 molar solution of phenol? What will be the degree of ionization if solution is also containing 0.01 molar sodium phenate? First we are taking phenol, which dissociate into phenoxide ion and H ion. Initial concentration of phenol is 0.05 molar. Phenoxide ion is 0, H ion is 0. After dissociation, the concentration of phenol will be 0.05 minus X. Phenoxide ion will be X, H ion will be X. Ka is equal to X into X divided by 0.05 minus X, which is given to be equal to 1 into 10 to the power minus 10. X square over 0.05 is equal to 1 into 10 to the power minus 10, because X is very small. So X square comes out to be 5 into 10 power minus 12. X will be square root of 5 into square root of 10 power minus 12. That is 2.2 into 10 to the power minus 6 molar. In the presence of 0.01 molar sodium phenoxide, suppose Y is the amount of phenol dissociated. Then at equilibrium, concentration of phenol will be 0.5 minus Y, which is nearly equal to 0.5. Phenoxide ion will be 0.01 plus Y, which will be nearly equal to 0.01. H ions we take it as Y moles. Ka will be 0.01 into Y divided by 0.05, which is given to be equal to 1 into 10 power minus 10. Y comes out to be 5 into 10 power minus 10. Alpha will be equal to Y divided by C, 5 into 10 to the power minus 10 divided by 5 into 10 power minus 2, comes out to be 10 to the power minus 8, which is degree of dissociation. So due to common ion effect, degree of dissociation of phenol becomes much less and reduces to 10 to the power minus 8. Next question, the ionization constant of acetic acid is 1.74 into 10 power minus 5. Calculate the degree of dissociation of acetic acid in 0.05 molar solution. Calculate the concentration of acetate ion in the solution and its pH. Acetic acid dissociates into HN and acetate ion. Ka will be equal to molar concentration of acetate ion into molar concentration of HN divided by molar concentration of acetic acid. Acetate ion concentration and HN are equal, therefore we can write HN whole square divided by molar concentration of acetic acid. HN concentration will be equal to 1.74 into 10 power minus 5 into 5 into 10 to the power minus 2. On calculation, we get 9.3 into 10 to the power minus 4. So molar concentration of acetate ion equal to HN equal to 9.33 into 10 power minus 4. pH will be equal to minus log of 9.33 into 10 power minus 4. 4 minus 0.9699, 4 minus 0.97, 3.03 will be the pH. Next question, it has been found that pH of 0.01 molar solution of organic acid is 4.15. Calculate the concentration of anion and the ionization constant of acid and its pKa. Ha dissociates into H positive ion plus A negative ion. pH is equal to minus log of HN, or log of HN is equal to minus pH, minus 4.15. We cannot see the anti-log of negative number, so we'll add 1 and subtract 1. Minus 4 and minus 1 means 5 bar, and 1 minus 0.15 is equal to 0.85. Now anti-log of 0.85 you have to see, it will be 7090. Put the decimal after first, 7.09, and 5 bar means 10 to the power minus 5. So HN concentration is 7.09 into 10 to the power minus 5 molar. A ions and H ions concentration of A negative and H negative will be 7.08 into 10 to the power minus 5 molar. Ka is equal to molar concentration of H ion into molar concentration of A ion divided by molar concentration of Ha. 7.08 into 10 power minus 5 whole square divided by 10 to the power minus 2. Answer comes out to be 5 into 10 to the power minus 7 molar. pKa will be minus log of Ka, minus log of 5 into 10 to the power minus 7. 7 minus log 5 is 0.6990. So pKa comes out to be 3.30. Next question, assuming complete dissociation, calculate the pH of following solutions. 0.003 molar HCl, 0.005 molar NaOH, 0.002 molar HBr, 0.002 molar KOH. HCl when dissolved in water gives you H positive ion plus Cl negative ion. Concentration of HN will be equal to concentration of HCl, that is 3 into 10 power minus 3. pH is equal to minus log 3 into 10 power minus 3, which on solving will give you 2.52 because log 3 is 0.4771. NaOH dissociates in water into Na positive and OH negative. OH is given to be 5 into 10 power minus 3 molar. HN will be 10 to the power minus 14, that is Kw, divided by OH concentration 5 into 10 power minus 3. This comes out to be 2 into 10 power minus 12 molar. pH is equal to minus log of 2 into 10 power minus 12. That is 11.70 will be answer because log 2 is 0.30. HBr dissolves in water giving you H positive ion plus Br negative ion. Molar concentration of H positive ion is 2 into 10 to the power minus 3, which is equal to concentration of HBr. pH is minus log of 2 into 10 power minus 3, which comes out to be 2.70 because log 2 is 0.3010. KOH when dissolved in water gives you K positive ion and OH negative ion. OH concentration is 2 into 10 power minus 3 molar. HN concentration will be Kw into molar concentration of OH ion. That is 10 to the power minus 14 divided by 2 into 10 power minus 3. This comes out to be 5 into 10 power minus 12. pH is equal to minus log of 5 into 10 power minus 12, which comes out to be 11.30.